So at the beginning of the unit, we said that the magnetic force can be either attractive or repulsive. So magnetic force can be either attractive or repulsive. And this is very similar, as I mentioned, to the electrostatic force in the sense that it will be an attractive force when we have opposite poles in contact with each other. So north is attracted to south. And it will be repulsive when we have like poles. So like poles repel. In other words, north and north, or south and south. And I want to show you some magnetic field diagrams that will help understand, because it's going to come right back to what we were talking about with there being a uniformity of spin. That is what produces an attractive magnetic force. When between both magnets, there is a uniformity of the directionality of spin. Okay, so let's talk about drawing magnetic field lines. Drawing magnetic field lines. Okay. And before we can talk about drawing magnetic field lines, I want to just mention that these are always drawn as though a compass is being moved around a magnet or a set of magnets. In other words, the directionality of these field lines is always going to indicate which way the magnetic north would be pointed on a compass. Okay, so let's talk very briefly about compasses and how they work. So a compass actually operates by having a freely floating bar magnet on a pin. Okay, so this little bar magnet has a north pole and a south pole. So compasses operate, so these operate by having a tiny bar magnet free to rotate around a pivot point. Okay, so anytime we draw our field lines, it's always going to be indicative of which way north would point on your compass. Okay, so let's start by drawing the magnetic field around one bar magnet first. So here we have one bar magnet. So let's start by drawing magnetic field lines around one singular bar magnet. Well, these field lines are indicative of the direction that north would point on a compass. So if I were to take a compass and put it down right over here at the corner we know that north on this compass is going to repel away from north on this bigger bar magnet. So actually, this first line is going to be pointed up towards the corner. So I'm going to just draw that in. I'll just put a little point here. Now, if we were to move this compass to this point, right over here, what's going to happen is our needle is going to start to deflect with north pointing towards the South Pole. So it's going to start to attract to the South Pole. So I'm going to draw another point where north on our compass would be attracting to. And what you're going to end up with is a loop that looks something like this. If we were to follow through by moving our compass in each successive position. Because once we get to this last point over here with our compass, we know that north is going to attract towards the South Pole because we know that opposite poles attract. So here's my first field line. But what I want to say to you is that there are some rules about drawing magnetic field lines. And the rules are that these field lines should always form a closed loop. And that is how we demonstrate the polarity and the directionality of that electron spin. So I'm going to go ahead and close this first loop just like this. Okay. So you can put some arrows in just to show the directionality of it. And now I'm going to go down here to this other end. So if I were to put my compass down here and know that north is going to repel away from north, and ultimately it's going to come back to attract towards south. So I'm going to draw my little arrows in to indicate that the north pole on my compass is going to repel away from north and towards south, and then I'm going to just close that loop so that I am abiding by my magnetic field line rules. Okay, so you're going to end up with a diagram that looks something like this. Sometimes people will draw these like this. So it could go north to south, and then inside south to north, north to south, and inside south to north. Okay, so that's another, like, they don't have to bubble out as much as this one did. But basically, if we were to add some additional field lines in, we know this might go up here, this might go down here. Same thing, but this is now going towards to close off this loop, and this is now coming towards to close off this loop, and so on. So this is just an example of what my magnetic field around one bar magnet with the north and south pole would look like. Okay, so there are a couple of rules for drawing field lines. So let's just talk about those briefly. So rules for drawing field lines, specifically magnetic field lines. One, external to the magnet, the field lines go from north to south. However, internal to the magnet, the field lines go south to north. And that is because we need to always complete our loops, which is going to be our third rule. So internal to the magnet, field lines go south to north. And our third rule that I'm just going to write down here is that magnetic field lines always form closed loops. Okay.